Hello class, my name is Ashwini. I am working as an assistant professor in the Department of Civil Engineering at Maharaja Institute of Technology, Mysore. So, from the previous sessions, you have been dealt with the other 4 modules of the green buildings, where the first module was all about the alternate building materials which were being dealt to you, where not only the conventional materials which are used for the construction of the building are not only the things which could be used, or we do have alternative materials out of which we can have a good environmental friendly as well as the cost effective materials which could be used. So, further in the second module you also got to know that the various technologies, construction technologies which could be used in order to carry out a construction process where they can also be environmental friendly and cost effective. Further in the module 3 you got to know that what are the various ill effects and how the global warming is being caused and what is the contribution of your buildings or the construction towards the global warming and how much it is being contributed, and finally what can we do in order to reduce it. Further in the module 4 you got to know about various agencies or the systems which are working over it and which are the agencies which are going to help you to rate it, and their work is not only to rate a particular building which is going to adopt these sustainability or alterations apart from the conventional materials, but also they are going to help the other people acquire the knowledge about the same and help them to further utilize the various properties. And now in the 5th module you will all be learning about the energies. You got to know the materials, you got to know the technologies, you got to know how the construction is contributing towards the global warming or the climate change, and finally you also got to know that what are the agencies which are helping us, and now you will be studying the energies that are going to be utilized in our building and how are they going to be precisely used, even if you and me are knowing more of it, but still we are not using it in a precise way, or in a, we can say that even if we know the things which is already present, we are not inculcating it in our day-to-day life. So, this module 5 consists of 2 parts. The first part, where the first part is all about utilization of solar energy in buildings, and part 2 is all about green composites for buildings. So, in the upcoming sessions I will be dealing about this, as well as in the part A or both included together. The topics that I am going to cover in this module is, the first one is the passive solar buildings. Under that I will be dealing with the passive solar heating systems as well as the passive solar cooling systems, and will also undertake some of the case studies. Next, further I will be dealing with green composites. Next, water utilization in buildings. Next, I will be dealing with the low energy approach approach to water management. Low energy approach to water management. Further, I'll also be dealing with the solid waste management. And you'll also get to know that how the sewage and sewage water management is going to be considered. Okay? And you'll also get to know that what is that minute or a smaller difference between your sewage and sewage water. And finally, I will be dealing with your green cover and built environment. Okay? So these are the topics that I am going to cover in the upcoming sessions or in this 5th module. Now let's speak about the passive solar building. What do you mean by passive solar building? What is it? The word itself is letting you know that it is a passive system and I am utilizing the solar energy in a building. So it means that a building which is going to utilize the solar energy for the fulfillment of the energy in a particular building without the use of any mechanical or the electrical devices or the equipments in it is said to be the passive solar system. These buildings will never use these energies which are going to be demanded. Instead, they are going to generate their own energy and give it to a building in order to place a human being or place a living being comfortable. Okay? Now let's see what is the concept of green building. So, green building or the passive solar buildings. Okay? So, what are the concepts of passive solar buildings? The passive solar building concept is majorly based upon the elements which are being used or which are being present in a building, and it is majorly dependent upon the windows, walls and the floors which are going to absorb the solar energy during the daytime, and the same energy will be radiated or distributed throughout the entire building at the cooler atmosphere or during winters, where the room can be kept warm and the comfort is present for a living beings. And passive, as I already explained to you, that passive comes because I am not going to utilize any mechanical or electrical devices in my building. Fine. Now let's see what are the principles based on which my passive solar system runs. Okay? Principles. So the first principle is the root of sun. The root of sun. The root of sun. It's nothing but during summer the sun will be at a greater elevation, right? Because we all know that our earth, it is not a sun which is going to move, it is an earth which is going to be revolving and rotating, right? So our sun will be at a greater elevation during summer, and during winters it is present at the lower elevation. So once, if I am going to consider a building or a structure in this way, okay, during summer the sun will be at a greater elevation where it rises and sets, okay? Whereas during winters it will be at a lower elevation. It will be moving like this, fine? Where the shifting of the sun will be present, that is only because of the tilting up of our earth, that's it. So now the second thing is during winter, the doors, the windows or the openings which are being located at its south. If I consider this to be east, this to be west, okay, and this is going to be your north and this is going to be your south. So the windows which are being located at the south will be receiving major amount of sunlight or the sunrise, okay. So during winter the major amount of sunrise or the light will be obtained by the windows or the openings which are being placed at the south. More energy, that is nothing but your solar radiations, okay. The next principle is, where have you placed your thermal mass? Once when we have a greater amount of openings, where is this radiation going to be falling and where is it going to be stored? So therefore, it is the thermal mass which is going to be located over your floors, which is going to be observing and storing the heat energy. So the location of what? Location of thermal mass. Location of thermal mass. What next? Next, in order to avoid the overheating up of your house or a building, we do have the shelters or the shades or the hangings which will be avoiding the excess sun rays. Fine. So that is overhangings in order to avoid your excess heating up of a building, which are also said to be the controllers for that particular passive building. Controllers, okay. Then the last one is the proper ventilation. The proper ventilation, okay. So proper ventilation will be helping us in avoiding the overheating up of our building, as well as it will be helping us to have a good air in our, or a good livelihood in our building. And further, we do have to have a proper insulation. Proper insulation. How is it going to help us? Proper insulation. Proper insulation is when once you have the heat being trapped inside your building, the heat should not get out, right? So that is how the insulation is going to be happening once when radiations have been captured inside your home. Now, it's a winter and you don't want any heat air, sorry, I mean to say it's a summer now and it's already been warmed up and now your building has to be cooled. Now in order to cool this system, the excess heat that is going to get inside should not be coming, right? So that is how you are going to insulate the building. That is, during summer, the excess heat should not enter into your building, and during winter, whatever heat is being trapped or whatever source or the energy is being present inside your building should not get radiated out. So this is all about the principles based on which your passive solar system runs. Now let's see what are the elements. Let's see what are the elements that are being considered or present in a solar passive system. Okay. Now, So let me draw a sketch first. So if at all I am going to consider this to be a structure, it's a foundation over here, fine. So say for example it's a frame structure, so I am just drawing it like this. Okay, and this is your floor, okay. This is your roof, fine, okay. Let me provide you a bit like an, what do we say, a 3D looking sketch, where it will be very much easy to understand, okay. So this is where you are going to provide a shade, or you are going to close it whenever the sun rays is too much, or whenever the heat which is present already inside your room is sufficient. And this is your floor, okay, this is your floor, okay, I am just shading it in this way, that's it. Now, so as I have already told you that the sun will be at a greater elevation during my summer, right? How can you say that? Like you might have seen during summers that once when it is 12, the exact shadow that will be formed beneath you is not at all seen. Like you will not be able to see the shadow at all. It will not even move, not even an inch. But once during winters, even at the 12, you will be able to see that slight variation in the shadow, through which you can make over that there is a tilting or the root change of your sun. Okay, so this is when the summer sun, I'll just place it at summer sun. And next, during winter, my sun is at a lower elevation, so winter sun, fine. Now what happens? The radiations of sun are going to come, okay. First let me explain with our winter sun. So once the radiations are being coming or entering or falling into a particular building, some of the radiations will obviously enter into the building through the openings present in a building, right. So these openings are nothing but, it can be a window or any certain type of glazing openings, glazed openings. So this I can call it as aperture, which acts as a capturer, or which captures the sunlight into your building, which allows the sunlight to enter into your building. So what is the function of this aperture or the opening? To capture. Next, whatever the sunlight is falling through this capture or through this aperture over your floor, it is going to absorb that heat. So this floor is going to act as a absorber. Fine. Now the floor is made up of some of the concrete elements, which is capable of, it can be a concrete element or any other flooring material which is going to be having the ability or which is capable of storing these heat radiations in it. So those are nothing but, or this is nothing but the thermal mass. Okay. So what is this thermal mass going to do? Once the absorbed energy is been coming to a particular material, it is just going to absorb it and store it. So once this solar energy is been stored in this thermal mass, during the cool sessions or during the cold atmosphere, or once when the temperature is lowered at the atmosphere, what happens? These heat radiations are going to radiate inside the room or a building. So it is just getting distributed. So distribution of the solar radiations or the heat radiation is taking place. Now, in order to avoid the excess heating up of this building during summer, the summer sun, as it has got a higher elevation, okay, if I am going to use the eaves, or if I am going to use the shades, okay, or the overhangings, what it is going to do? It is going to restrict, okay, or it is going to control the excess heat radiations which are going to get inside a building. So these, I mean to say this, so these overhangings are nothing but your controllers. Okay, controllers. Okay, so these are the elements which are present in a passive solar buildings and their working principles. So now tell me, which are the various elements which have been present in a particular passive solar buildings. So first one is your capturer. Once the heat or the light is being captured, it is being let into your building, and then what is happening? The absorption of those light or the solar radiation is happening. Once the absorption is being completed, or at the process itself, what is happening? The thermal mass is trying to store the energy or the heat radiation. Next, once the temperature is getting down in a building, what is happening? The distributors are trying to radiate those heat energies throughout the building, which is providing the warmth to the building. Again, what is the last one which is helping you to control the overheating of your building? That is the controller, or the controls that we are going to provide as eaves or the overhangings or the shades, which will be helping us to avoid the overheating up of a building by providing us a shade. Now, next, let's see what are the benefits of this passive solar system. What are the benefits of this passive solar buildings or the systems? So, tell me. So, the first benefit would have been, it's like the excess energy or the excess electrical energies or the energies which are providing a more carbon footprint, which are causing a quite global warming, will be reduced. So, low energy requirement, that is outsourced energies, requirements. Okay, so outsource is not required for me, only with the natural light and heat it will be done. Next, what is the other one? It is high amount of ultraviolet radiations, or the ultraviolet rays will be prevented by entering into the building, through which various other harmful effects which will be caused by the ultraviolet radiations will be prevented. Fine. And then the bright appearance of the interiors will happen. Bright appearance. So, bright appearance of a building interior will happen. That is, due to the excess lighting, the glades will not be present, right? Or due to the irrespective, or due to the low amount of openings or the less amount of openings in a building, the dull effect will not be present. So, glaring as well as dull effects or a down effect will not be present. Hence, the bright appearance will be present in a particular building. What is next? So, during summer you will be having a cooling effect. Okay, during summer, cooling effect inside the building. Okay, and during winter you have the warmth inside. Winter is warm. So, during summer the excess heat won't be coming into it, and the system would be cool enough in order to have a good comfort in our building. As well as during winter, we won't be finding so chill that we want a heaters in a building. Instead, our solar energy passive system buildings can only take up the warmth and provide a comfortable living for a living being. So these are the benefits of the passive solar system. Now let's see what are the disadvantages or what are the ill effects of our passive solar buildings. Majorly there are only two. One is the overheating, okay. So one is the overheating up of a building, and that can be avoided as I have already dealt, or as I have already told you, it can be prevented by using a respective shades, right, and using a controllers. I can overcome it. But how does this overheating happen? This usually happens because of the negligence shown by a designer. If the orientation varies, if at all there is a design criteria which is going to be altered, or if there is any mistake present in the construction. So this may cause your overheating, but it can be resolved. It's not like I cannot resolve it. But the other one is the perception. How a particular people or how a particular person feel when a new research is been coming into. So what happens? The difficulty or the problem is between you and me, that we are not ready to take a new technology coming. Instead, we need to have a good perception by knowing the concepts which are being present in this technology. So the designers, the public, okay, the contractors, they are not ready to live up their designs, their criterias and the aesthetical appearance of a building for the sake of a aesthetical appearance in case of my energy conservation, right. So they are not ready to live all these things in order to conserve the energy. So if at all I have a concern about my energy, or if at all I have a concern about my solar system, about my Mother Earth, I will surely be concentrating about the energies which I have to serve or reserve, and also what are the impacts that are going to be falling on it, and also how would I help my Mother Earth instead of just keeping all these things ahead, okay. So now let's start with the next concept, that is passive solar building design. So it is very important that whenever I am going to take a particular project, so what are its design criteria and what are its design parameters that I have to be remembering in order to have a effectively and efficiently working system. So the first one is location with respect to the sun, that is with respect to the solar radiations or the heat energy that are getting into a building, where have I placed my openings, that is the window openings, the horizontal or the vertical openings through which the sun is going to be directly falling into the living area, where the capturing of the heat radiation is going to happen. So that becomes very much important, where I have located my building. Next, structural design or the structure design. It all depends upon the shape and orientation of a building. So where and how, in which direction the building is being placed. And it is usually recommended to have a greater length in the east-west direction. So that is, the building is elongated in its east and west direction. Okay. So the next one is paying attention to the north side. We all know that, as I even discussed in the discussed previously. So what I told, during winter the sun is going to be radiating through the south, right, and the north side wall is not going to have any function, and it's not going to absorb any heat from the sun, right. It is not going to be subjected to a greater extent to the sun or the solar radiation. So why to simply increase the height of the wall there? So what it means is that, so instead of increasing the height of the north side walls, so we can reduce it, which would make the building economical, as well as by placing the reflectors adjacent to that north wall may reflect the energy towards the north wall and which may increase the absorption of the north wall, right. So, in that way if I am going to be concerned with the north side, so I can make a best out of a waste. So, the picture which is being projected out there, you can have a look and understand it much more clearly. The next one is allocating interior rooms. So, wherever the heat energy or the utility of that particular room is very high, okay. So, if at all I am going to use a particular room for a greater duration and a time, obviously it means that a good amount of light and heat should be present in that area. So, those kind of rooms can be placed, where can they be placed? As the south side will be having a greater amount of radiations. So, I can place those areas and living rooms towards the south, southeast or the southwest direction. And the rest such as the corridors and the not much utilized areas can be placed towards the north. Next, the window location. So, the window location, it is nothing but where am I going to place the openings of a room, where it is going to serve the purpose of the capturing of a heat into my living area, right. So, if I am going to place these windows at a site where the maximum amount of heat can be collected, then the purpose of the design or the purpose of the building which is been designed for the passive solar heating could be effectively working. Next one is the sheltered entrance. It is quite interesting. So, sheltered entrance, it is nothing but during a winter season, whenever I am going to open the doors, if a cold breeze enters or a wind is going to blow, what happens? The cold breeze is going to enter into a room which will be again altering the atmosphere or fluctuating the temperature present inside the room, right. So, in order to avoid that, if I am going to have the sheltered entrance, what happens? The amount of wind which is going to enter into it will be avoided. So, how can this be done? Instead of just placing a opening, that is your door next to the wind blowing direction or next to the openings which have been provided where the wind blow or the entrance of the wind is feasible. So, instead of providing that, making it away from that place. And also if at all the orientation is not possible in that way, we can use a wind shield in order to avoid the wind entrance into the rooms or the building during the winter season whenever we are going to open the door. Next one is the system selection. So, each and every project has got its own importance, as well as each and every project will be having a design criteria, right. So, as our own taste keeps on varying, so this is also as such, right. So, let me take an example here. If a building, if I am going to construct a building which is having this passive solar system in it, I am placing a opening all around, like the most of the openings are provided at the south, okay. But the major issue here comes that the entire building is surrounded with the other buildings which are at a greater elevation, okay, or which are elevated to a greater extent. So, now the openings which you have provided for a building is not serving the purpose. The amount of heat energy that has to be get into the building is not coming. Now, what are you going to do? Is it serving the purpose of solar passive heating? No, right. So, the system selection becomes important. So, instead of providing those openings and glazings in the surrounding or in a south direction, if at all I am going to provide it at the top overhead, so it might be serving the purpose. So, this is how I will be selecting the system based upon the location as based upon the various projects that I am going to undertake. The next one is the solar windows. So, solar windows, as most of the time the windows we are going to use will be a glazed ones. which will be serving the purpose of the passive solar heating. So what this solar window should be having? So it should be projected at the south side where the greater amount of heat is coming, and it is recommended that a minimum of 0.1 square feet to 0.45 square feet opening has to be provided for every 1 square feet of the floor area. Okay. So this is what is recommended for our solar windows in order to have a proper and effectively functioning passive solar system. The next one is skylight. So what is this skylight? I even discussed while I was discussing in the system selection. So the openings or the glaze which will be provided at the top are nothing but the skylights. So depending upon the requirements of a particular building and the location, I will be using the skylights, which will be enhancing the efficiency of a passive buildings. Okay. So the next one is the masonry heat storage. As the thermal masses which we are going to utilize in a passive solar buildings plays a major role. Okay. So these masonry walls which I am going to construct for my building should minimum have a 4-inch thickness, okay, which will be effectively absorbing the heat energy and then storing the heat energy in it. Okay. So this is what becomes very much important in case of your masonry heat storage. The next one is the interior water walls. If at all I am going to use the interior water walls in order to store the energy which is going to be absorbed, instead of using a floor which is going to act as a thermal mass, now my water walls are going to act as a thermal walls. Not to worry, I will be explaining it to you along with the diagrams in the upcoming sessions, which will be making you understand much easier. So what happens if I am going to use a vertical walls which are of water, okay? If I am going to use those water walls, okay, for the energy storage, it becomes important that a sufficient amount of heat energy is getting into or is falling over my water wall, okay? So water wall should be able to receive a greater amount of heat energy, right? So that this water which is going to heat up and cool up slowly compared to the other materials is going to get a quite good amount of heat energy which will be serving the purpose of passive heating, right? So therefore we need to place this wall in such a way that the sun's peak light, or during the peak time the sun's energy is maximally falling over this water walls. So what happens? You are supposed to see to it that it is placed maximally towards the south, right? And at the same time, so the peak hours of the sun is majorly dealt to be between the 11 AM to 3 PM. And during that duration, so daily light is going to fall over that material, so the water walls which will be capturing the heat, right? So the next one is the thermal or the therm wall. Again, instead of directly letting the heat into the ground surface, I am making a barrier over here, that is nothing but a vertical wall. So here I was using a water wall, now I will be using a wall, masonry wall or any wall material, okay. So which will be taking up the heat, absorbing it and radiating it later when the atmosphere in the room is going to come down, and this process will be happening not directly but through a conduction process. The material, when it is going to heat up at this side, through conduction the heat is going to come towards the other end of the wall, and then finally the heat is going to get radiated, and the other side is usually going to be heated up most probably during 4 to 5 p.m. because the heat energy has to reach from one end to the other end, right. So this property depends upon the material that I am going to select. So thermal wall. So thermal wall or therm wall is that wall which has to be selected. So next one is the wall dimension. So the wall dimension here is majorly with respect to the interior water wall that I am going to provide and the thermal or a therm wall that I am going to provide. It is recommended that 0.45 square feet to 1 square feet of thermal mass wall or a therm wall is provided for every 1 square feet of the floor area. If I am going to use a therm wall. If I am going to use a water wall for that purpose, then it is recommended that 0.31 to 0.85 square feet of the water wall is provided for every 1 square feet floor area. Okay. So this is how the wall dimension is been recommended or plays a major role. The next one is adjacent greenhouse. It is quite complicated to design an adjacent greenhouse because the energy has to be derived from the greenhouse to the adjacent building or a living area which will be dependent upon this greenhouse. Therefore, it becomes very much important to have a correct calculation of the greenhouse dimension, right. The next one is freestanding greenhouse. Quite interesting, like we all know that the greenhouse will be constructed by using a glazings, right. So glazes will be present. So and these glazes are usually translucent in nature. So the whatever heat radiations or the solar energy is going to get in will be trapped inside for a greater duration, right, because it has also got a quite insulation property. But in order to have a proper working and a good efficiency of a building even during the winter seasons, we need to have a thermal storages inside the greenhouse where such as the rock storages can be utilized or the water can be utilized as a thermal storage or any other concrete masonry walls would be serving the purpose which are going to be constructed inside a freestanding greenhouses, right. So the next one is the roof pond. Okay, so this becomes important in order to know that why am I providing this roof pond, whether it is to cool a building or whether it is to heat a building. So what is the purpose going to be served by the roof pond, okay. So it is recommended that we need to have a minimum of 6 to 12 inch depth. So these water ponds should be at least having a depth of 6 inch, okay. And these water ponds or the roof ponds should have a dark color covering or a paint over its surface, right. At the same time, these should be insulated and watertight, like the paintings should be a waterproofing painting should be provided over the surfaces so that it is watertight. So why it is required? Why do I require that? Instead of serving the purpose of heating and cooling, it should not leak, right. That is the reason it is very much important in order to seal and watertight a system. As the pipes will be let out through the same roof pond, okay. So it is very much important to see that it is a leak proof or waterproof. So next one is the movable insulation. Whenever the insulation is required for a building, okay, in order to avoid the moving of a warmth or a hot air present inside a building, we will be using this movable insulators. So 90% of the heat radiations which are going to be exchanged due to the variation in the climatic condition can be reduced using this movable insulation. Okay, so that is nothing but the insulators will be like the screens will be moved, like the way you are going to move a screen in order to close a window. In that way we are going to move our insulators from the outside towards the various materials that we are going to use. Okay. So the next one is the reflectors. It is very much interesting, like whenever the openings which we have provided to a building is not getting a sufficient amount of energy, or whenever the area which has to be covered is greater when compared to the opening which is present. In order to increase the efficiency of the solar radiations which is going to get into a building, okay, we will be using the reflectors at the top or at the bottom. There are many such buildings which are using this criteria. Okay, I'll let you know once when I am going to start the case studies. Okay. So now the reflectors, like it runs on a principle that we all know that the mirror, what it happens once when a radiations are going to hit, it gets reflected in the same angle. So incident and a reflected ray have got a same angle of inclination. So using that major phenomena or the principle, these reflectors are going to direct the sun's radiation into the building, right. So that is how it is going to increase the efficiency of a passive solar system. So next one is the shadings. So these shadings are nothing but the external projections that are going to be provided for the openings in order to avoid the excess heating up of a building, or in order to reject the excess amount of light entering into a building. So usually as per the recommendations, the shading should be minimum of 1/4 of the height of a opening that I am going to provide. So whatever I am speaking, you can see in the projections, which will be giving you a clear picture of all the things I am speaking. So now the last one is the outside insulation. So it is nothing but whenever I am using a thrombol and a double glaze system outside, okay, you will be getting it to know detailedly in the upcoming sessions. So if I am using such type of structure, so what happens, this is a wall, this is a glazing provided. So this is a air gap which is present between the thrombol as well as a glazing. So this heat energy, though the thermal mass or the thrombol has heated, and due to the conduction process it will be heating up or providing the warmth to the internal surface of my building, still there is a gap between these two. Even though I have made a specialized glass which will be self-insulating, still a quite amount of radiations may go out as a greater lowering of the temperature takes place in the atmosphere. So in order to avoid that escape of heat energy through the glaze surface, I will be using this outside insulation or the outside insulators. Again, these are movable, and I will be covering the entire surface of a glaze with this outside insulators. Okay. So we do have a quite greater amount of design aspects which we have to remember, but this would be sufficient as per the syllabus. Okay. Okay.